Hello everyone. CONSTEKNOSforum welcomes all you construction technocrats. For a long time, some of my friends and viewers were demanding a video on measurement and calculation of tilt and shift of well foundation. So, here I am presenting the same for you. First, we will understand the sinking of well and its tilting during sinking. For understanding about well foundation in detail, please watch the video on well foundation. Its link is given below in the description. To sink the well, we remove the soil inside the dredge hole from the bottom of the well. In this way, we create a sump under the cutting edge, and eventually the well sinks under gravity due to its self-weight. When the well sinks by self-weight, the soil inside the shaft is dredged by suitable means, which aids further sinking into the ground. If everything is normal, the well smoothly sinks vertically downward. But this does not happen every time. Sometimes the well tilts in one direction due to a hard layer or an obstacle coming in the way of the well sinking. This tilt results in rotation of the vertical axis of the well, which was perfectly vertical before the tilt, and hence the well gets shifted horizontally from its original position. In fact, tilting is the main reason for the well shifting. The amount of shift at top and bottom of the well depends upon the location of the rotation point corresponding to which the well is tilted. Let us now see how tilt and shift are measured and calculated. After the well curve is cast and the shutter is released, a scale is painted in 4 locations on the outer face of the well curve. These 4 scales are located perpendicular to each other, 2 along longitudinal axis and the other 2 along the lateral axis. The zero of this scale is matched to the cutting edge and gradually move in the upward direction with each lift of casting of the well steining. This scale marking has 2 benefits. Firstly, it represents the total depth of the well sunk, and secondly, the tilt and shift that occur during the sinking process of well are calculated from observations taken on these scales. One thing needs to be paid attention to here. This is a very common mistake made by engineers or supervisors in the field. After the previous lift has been sunk and while the well is being prepared for the next lift, the shutter is kept upright to maintain the verticality of the well. In this way, we deviate from the original axis of the well, which is absolutely wrong. To maintain the original axis of the well, it is necessary to fix the shutter along the original axis and not in the vertical direction. And similarly, the scale should painted on an inclined axis instead of a vertical axis. Another important thing is that the top surface of the well cannot be cast perfectly flat. There will be always be some irregularities. So, while taking the level for tilt measurement, it should be taken on the gauge marking, and all the levels on the 4 gauges should be taken on the same gauge reading. Like in this example, 4.875 meter. Suppose this is the plan of a circular well and these are the 4 gauges marked on the 4 outer side of the well. This is the elevation of the well along the bridge axis, that is longitudinal axis, and this is the elevation of the well across the bridge axis, that is lateral axis. The well may tilt towards abutment A2 or abutment A1 or any other direction. It must be remembered that we have to calculate the shift at the bottom of the well and not at the top of the well. And to calculate the shift at the bottom of the well, we have to take measurement at the top, and based on that data, the bottom shift is calculated. Now, we will discuss the step-by-step procedure to calculate the tilt and shift of a well. Step 1. Taking measurement at the top of the well. All the 3 coordinates, that is x, y and z, should be taken at the same gauge marking of all the 4 gauges. In our case, the gauge marking is 4.875 meter. With the help of xy coordinate, the actual position of the well top at present can be easily determined, and the shift of the well top in both directions, that is longitudinal and lateral direction, with respect to the designed position can be established. Step 2. Calculation of the tilt of the well. Let us assume that the well is tilted at an angle of theta. This angle will be same as the angle of inclination with the horizontal at the top of the well. If d is the distance between two opposite gauges and y is level difference between opposite gauges, then tilt will be y by d%. Similarly, tilt can be calculated in the perpendicular direction as well. Step 3. Calculation of the shift at the bottom of the well. Once the tilt is known, the shift of the well center at the bottom relative to the well center at the top can be easily calculated by the simple triangle formula. In our case, the total depth of the well up to the gauge marked is 4.875 meter. If the shift at the bottom is S, then the amount of this shift will be equal to y divided by d multiplied by 4.875 meter. Similarly, bottom shift can be calculated in the perpendicular direction as well. It is important to note here that this is the shift relative to the top of the well and not an actual shift from the original design position of the well. Hence, to get the actual shift from the original design position of the well, this value should be adjusted with the top shift from the original design position of the well, which is already established in step 1. To understand this, let us take an example. This is the vertical axis of the well as per actual design, and this is the well axis in the tilted position. S1 is the shift of the well top with respect to the designed position which has already been established in step 1. S2 is the bottom shift relative to the top of the well which has already been established in step 3. Hence, the final shift at bottom with respect to the designed position will be equal to the algebraic summation of S1 and S2. Let us assume that S1 is equal to 120 mm and S2 is equal to 280 mm. Hence, the final shift is equal to S1 plus minus S2, considering right side as positive and left side as negative. Hence, final shift will be equal to 120 minus 280, which is equal to minus 160 mm. Negative signs indicates that the shift is towards left side. Step 4. Calculation of the resultant shift at the bottom and the resultant tilt of the well. This is the plan of a typical circular well. This is the elevation along the longitudinal axis of the bridge, and this is the elevation along the lateral axis of the bridge. If the well is tilted about a particular axis, such as the longitudinal axis, then the tilt about the other axis will be 0. But in reality, this is not the case. The well can be tilted in any direction. Therefore, it is necessary to calculate the tilt and shift along both axes and then evaluate the resulting magnitude of the tilt and shift and its resulting direction. Now, we represent tilt or shift by an arrow whose direction is the same as the tilt or shift and whose length is proportional to the magnitude of the tilt or shift. If these two arrows represent the magnitude and direction of the tilt or shift, then this blue arrow is the magnitude and direction of the resultant tilt or shift. The magnitude of the resultant can be calculated using this formula. All these calculations can be analyzed by graphical method using AutoCAD, but I have an easier and faster solution to calculate all these details and have a graphical representation of all the situations. Here I am presenting a software which is designed in Visual Basic for Excel to solve this problem. The best thing about this software is that it is very easy to operate. Even a beginner level user of Excel can operate it. And of course, it is almost free. The link of this video is given in the description. Please watch it and contact me if you need its Excel file. That's all for today. See you soon with a new topic. Till then, please allow me. Jai Hind, Jai Bharat.